Welcome back, students. We're going to continue talking about transformations with quadratics. Right here, little guide for you put into the notes just to help you remember what each of these does. So let's jump into this first problem. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x is equal to x squared. Write a rule for g of x and identify the vertex. Okay, so we're starting with the equation f of x is equal to x squared. Now there's 3 transformations here, but I think we can do 2 of them at once. So I'm not going to jump straight to g. I'm going to start with h of x. Now h of x is going to be a translation of the combination of the first two, the vertical stretch by a factor of 2 and a reflection in the x-axis. So you'll notice that's what a does right there when we're multiplying on the outside. So I'm going to take f of x and I'm going to multiply it by a negative to create the reflection, 2 to create the stretch. So negative 2 times f of x, which means that h of x would just be, f of x is just x squared, so this will be negative 2x squared. All right, so now we're ready to create g of x from that by doing a translation 3 units down. So g of x, I'm going to take my h of x, and then to translate it downwards, I'm just going to subtract a 3 from h of x output. And this will give me h of x was negative 2x squared minus 3. Great. So here is our equation that does all of those transformations. All right, let's do another one of these. Let the graph of G be a translation 3 units to the right, 2 units up, followed by a reflection in the y-axis of the graph of f of x equals x squared minus 5x. So a little bit trickier because we're not starting with the parent function, but something a bit more complex. But the same process still applies. Let's start out by writing our f of x is equal to x squared minus 5x. Now let's do h of x as kind of our intermediary as we move our way towards g to do this first translation that they gave us, 3 units to the right and 2 units up. So to make it go to the right, we're going to have to take f of x, and in the input, to subtract a 3. Okay, and that goes along with the section of your notes where we talked about horizontal translations. If you are subtracting a negative, or in other words, adding, that's going to shift it to the right. Okay? And now to make it go up, we're going to take the output and add a 2 to it. All right, so let's look at how that simplifies. What we have to do is anywhere we see an x in the f of x equation, we're going to replace that x with x minus 3. So rather than x squared, we have x minus 3 squared. Rather than minus 5x, we're going to have minus 5 times by x minus 3. So wherever the x was, I put parentheses and then changed it to x minus 3. Let's go ahead and simplify that statement. We'll have x squared minus 6x plus 9 minus 5x plus 12. All right, last simplification on this one. X squared minus 6 and a minus 5, so minus 11x's plus 21. All right, so we now have an equation for something that's going to go 3 units to the right and 2 units up. Now we're ready to finish it off with g. This was followed by a reflection across the y-axis. So g of x, we need to take h of x, reflect it across the y-axis. If you look earlier in your notes, you can see where we do a reflection across the y-axis. Notice the way to do it is to put a negative in front of the input. So I'm going to have my h of x become h of negative x, and that should create that reflection. So let's simplify that. Now, once again, just like before, everywhere I see an x, I'm going to put parentheses and change it to negative x. So rather than x squared, we have negative x squared minus 11 times by a negative x plus 21. All right, well, anything squared, so a negative times a negative is going to be a positive, so negative x squared is really just the same as x squared. A negative 11 times a negative x becomes positive 11x. And there you have it. There's our rule for g of x that is going to complete all of the transformations described. All right, let's look at a word problem with this. The height h in feet of water spraying from a fire hose can be modeled by h of x equals negative 0.03 x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. The crew raises the ladder so that the water hits the ground 10 feet farther from the fire truck. We want to write a function that models the new path of the water. Okay, so this one, I kind of want to visualize it to see what's happening. So I've prepared this here. Here's our equation to model the distance from the fire truck. Now, once it's hit 0, it's hit the ground. So nothing past 0 would really make sense. And we notice that it hits the ground at 50. Now, in the story, it told us we wanted to hit the ground 10 feet farther. So in other words, the fireman holding the hose, standing on the ladder, was raised higher so that the hose would shoot 10 feet further. So I think the question we need to answer is, how much higher do we need to make this graph go so that it's going to hit 0 at 60 rather than at 50? Well, let's go ahead and take a look at how low is it at 60. So it looks like it's down 23 places at 60. So if we were to raise this entire graph up 23 places, that would mean that we would also move it from going from 50 to 60. Okay? All right, so now we've got our plan. Let's go ahead and execute it. So we want to write the function that models the new path. We're going to, let's see, do they care? Just trying to see if they cared what function name we gave it. So I'm going to say that g of x will be our new function to represent the ladder raising the fire hose up. So g of x is going to be equal to h of x. and we identified that we needed to move it 23 places up. All right, so g of x is equal to, now let's go ahead and change h of x. H of x is equal to a negative 0.03 x squared plus x plus 25, and then the plus 23. All right, so there would be what we think the new equation is. Let's check it. Let's test it to make sure that that worked. So I'm going to take this equation. All right, and now let's just paste it back in. Go ahead and change that one to g. And let's see, we got this one to be 48. And we notice we did get 10 feet farther by doing that. Okay, now this was not the only way to approach this problem. We knew that we needed to get 10 feet farther. We could have also assumed that we could just do a horizontal translation, 10 to the right. So we could have done g of x is equal to h of, we want to go 10 to the right, so we'd have to minus 10. Now, we didn't do that for the sake of time, just because substituting in all of those x's and then simplifying it would have required quite a bit more work to do the horizontal translation rather than the vertical translation. But if you're interested, go ahead and test your math skills and make sure that both of these come out to be the same thing. All right, good luck on your practice.